We get really good deals on like material. So they make a milk product. I say the we have. We have. What makes it takes time. Exactly. Which all.
Beat it or troll. I would say that's right.
And now you got that other deal on raw material.
Okay, so sorry for the wait. Any questions before we get started? So first thing first, I want to actually mention to everybody that if you have a chance to check out the our team site, then we will start to have our partial credit activity go on, okay? So in the when you actually submit your doing this so you can see this better. So make sure you including all the information listed in your request. Okay, so make sure you actually put on your PeopleSoft ID and then screenshot the questions that you think you deserve some partial credit. Okay, and then show me how you get your number and explain why you think you deserve some partial credit for that. Okay, so I will actually base on your work and then decide how much partial credit you can get. So you need to do this until next Tuesday midnight. Okay, so after that, I won't actually accept the partial credit. Okay, so that's pretty much the first thing I want to cover. Any question for this? Okay, so if not, then get back to our note. So I got updates about the average for the midterm. We did, okay, so it's actually quite similar to last time. We still rank number 2 in the all sections. Okay, but the difference between the two sections actually becomes smaller. So I think we're actually improving. Okay, so I also see some students who did not so great in midterm 1, but actually improved quite a bit in the second round. Okay, so I probably actually reach out to those students and ask them what they have done to actually improve their grades. Okay, and I will share those information with everybody later on. Okay. One more thing I want to mention is that next week we don't have in-person lecture. I will actually upload the recordings on Teams. I guess later this week. Okay. All right, so that's pretty much all the things I want to cover before I actually get started. Any questions? So if not, let's continue our discussion then. Okay, so chapter 16 is all about thermodynamics. In the previous lectures, we start to tell you the concept of entropy. Right, so, and then we define the energy term, free energy. Okay, so free energy is actually the ultimate energy term that we need to actually use to predict whether the reaction will be spontaneous or not. Okay, so if your delta G is negative, then the overall reaction will become spontaneous. Okay, so one of the most important equations that we need to know is actually that delta S universe is defined as delta S system plus delta S surrounding. Okay, so that's actually the first equation. And then the second equation is that we know the delta S surrounding can be redefined as delta H of your system over the temperature. Okay, so if you multiply the negative T on both sides, then you got negative T delta S universe is going to equals to negative T times your delta S system plus delta H. Okay, and we define this term as your delta G. So therefore we know one of the most important equations for this chapter is actually delta G equals to delta H minus T delta S. Okay. So for a spontaneous process, your delta G will become negative. Your delta S universe will become positive. Okay, so this is actually pretty much the summary about the key things we went through in the Tuesday's lecture. Okay, so we're going to introduce you a couple more equations, then they will be actually complete the knowledge that you have for this chapter. Okay, you will know all the important equations that you need to have for this chapter. Okay, so I label this delta G equals to delta H minus T delta S. Okay, that's actually your key equation number 1 for this chapter. Okay, so the second important equation that we need to actually memorize is actually this one. Okay, delta G naught equals to negative RT natural log. Okay. Okay, so we kind of mentioned this concept in the previous lectures. Okay, so what you should know by now is that when the system reach equilibrium, the delta G of your system will equals to 0. Okay, so what scientists do is actually, let's say we define our system at the standard condition, okay, where all my reactant has a concentration of 1 m, okay, and then I do the experiment under a room temperature, 1 bar conditions, okay. So under that specific condition, your system will actually have a specific energy, okay. We call it energy delta G naught, okay. So that is actually what this term means, okay. Then you let the reaction go, okay, and eventually your reaction actually reach equilibrium, okay. So the energy difference between the standard condition and the equilibriums actually define the energy differences, okay? And that number will actually be defined as delta G naught. And since at equilibrium, you know your delta G is going to equal to 0, right? So delta G naught by itself will define the energy differences. Okay? And the energy differences can be actually associated with your equilibrium constant K using this equation. Of course, this equation is actually after we do a lot of observations, then we realize that there's actually a specific relationship between your delta G naught and the equilibrium constant K. Okay, so this will be actually the second equations that we're going to use a lot to solve the questions for this chapter. Okay. The third equation is that right now you know how to define your delta G naught. Okay. So if today I'm not at the standard condition, can I somehow actually use the relationship that I know to write out to connect your equilibrium state to a state that you have? Okay. So to do that, what we do is actually you first need to have a way to define the energy of the state you are interested in. Okay. Previously, we learned these things called the chemical quotient Q, right? So Q is actually the is actually the I guess it's Okay, so chemical quotient Q is actually a quotient that looks very similar to the equilibrium constant, right? The way you write out the equation is actually exactly the same as the equilibrium constant equation. Okay, the difference is that, okay, you can write out the chemical quotient Q for your system and any conditions. Okay, but when your system reach equilibrium, then the concentration of your reactant product raised to their corresponding powers, okay, it will become a constant. Okay, so we use Q to describe the status of a reaction at any given status. Okay, and then when your system reach equilibrium, then your Q will equals to K. Okay, so things right now, you know, you can actually describe the energy differences between the standard state and then the equilibrium state using this equation form, right? Delta G naught equals to RT natural log K. Okay. So if you want to describe the energy of your system at any state, okay, then let's say the energy difference between that is actually, this is actually specific for the standard state, right? Okay, so if today you are not at the standard state, you should be able still to write something like this. Okay, you can write a delta G equals to negative RT natural log Q. Okay, so the only difference is here is that you use Q to replace your K. So that the energy differences between the specific state to the equilibrium can be associated with your Q using a similar equations. Okay. So, but how do you actually put the Q and K together is actually, you can just write out the difference, the energy differences between the two. Okay, so your delta G, there's actually a third equation we want to say, okay. So your delta G will be actually the energy at a standard state minus the energy at a specific state, okay? So the third equation we want to write is delta G naught plus RT natural log Q. Okay, so this is actually a third equation that you want to write. Okay, so the delta G naught here is actually indicating your equilibrium state, right? Because your equilibrium state will give you this specific relationship, right? Delta G naught is actually related to your K. Okay, minus the energy at a given Q. Okay, so this plus, what it really means actually you minus negative RT natural log Q, right? So negative RT natural log Q is actually represent the free energy at whatever state you are looking at. Okay, so the energy difference between land will actually eventually dictate, okay, the overall energy differences delta Q. Okay, so these are the third equations that you want to actually memorize. Okay, so let's recap the three equations. First equation, delta G equals delta H minus T delta S. Okay, so that's actually the first equation that we want to actually learn for this chapter. Second one is that you can actually define the energy at the standard state, which is delta G naught. Okay, it can be related to your equilibrium constant K through negative RT natural log K. Okay. And the third one is actually, you can compute the energy difference of any states, okay? And then it will be actually references to your standard state, okay? So you have delta G naught first, okay? And then plus RT natural log Q. So these are the three equations that we want to get familiar with, and then use them to solve all the questions that we have for this chapter.
The analysis will just, standard.
Yes, so you see that little circle, little nut on the top right corner of the delta G, that just indicates it's at standard state. And at standard state, what it means is actually the reaction is actually performed under room temperature 1 atm, and then the concentration of your reactant is 1 m.
The third equation delta G naught, that gives us the difference between the standard state.
And then the and then equilibrium state, right? Because the energy of your equilibrium state equals to 0, right? So your delta G naught by itself can actually represent the energy difference between that state and then equilibrium state. Okay. All right, so these are the 3 equations that we want to use today. Okay, so we're going to go through the questions to tell you, okay, what are the keywords that you can actually find out and then know what equation to apply. Okay. All right, so let's look at the first equations. At 250K, delta G naught equals to a certain value. Okay, so I'm going to highlight a keyword here. Okay, delta G naught definitely is actually one keyword. Okay. It has certain value, okay, for this reaction, N2 plus 3H2 become to NH3. Calculate the value of natural log K. Okay, natural log K is actually another keyword you want to actually get familiar with. Okay, so you see the keyword is actually delta G naught, natural log K, right? So equation number 2 will be actually the go-to equation to use. Okay, so that you know, delta G naught is going to equal to negative RT natural log K, right? So be careful, okay? Every time you see like kilojoules, make sure you convert into joule, okay? So you know, on the left, your delta G naught is 4.157 times 10 to the third, okay? It's going to equals to negative, R will be 8.314. Temperature will be 250K, right? Multiply your natural log K. Therefore, your natural log K will equals to negative 4.157 times 10 to the third power divided by 8.314 times 250. Okay. Therefore, when you calculate this, you will be able to get your answer. Okay, and when you calculate that, you're going to get a value of -2. Okay, so this is actually how you solve question like this. Okay. Only 3 equations. Okay. First one, delta G equals to delta S minus T delta S. Okay, so second question is actually delta G naught equals to negative RT natural log K. Third equation is actually delta G equals to delta G naught plus RT natural log Q. Okay, so here you see the keyword of delta G naught. You see the keyword of natural log K. Therefore, you know you need to use the equation number 2. All right. Any question for this? No? What's the unit of R? 8.314. What's the unit of that? I multiply 10 to the first power. Okay, so just make sure the unit is actually consistent. Okay. All right, question number 9. The value of delta G naught. Okay, apparently it's actually a keyword. Okay. For the same reaction is a certain value at certain temperature. Calculate the value of delta G in kilojoule at that temperature. The partial pressure of H2, N2, NH3 is certain values. Okay. So here you see the keyword delta G naught. You also see the keyword delta G, right? And then the other feature of this question is actually it gives you the status of your reacting product, right? So those are the information you get here. Okay, every time you see a question that give you the value of your reactant and products, okay, that is actually a indication that you need to use your Q. Okay. So let me make that clear to you. So you see here, you say the partial product of H2, N2, and H3 is certain value, right? So you actually specify the conditions of your reactant end product. Once you see that, 99.99% of time, it's asking you to calculate Q. Okay, so this is actually a tip that you need to actually get familiar with. Okay, every time you see a question that tells you the specific conditions of your reactant product, meaning you need to actually calculate the Q. Okay, so we know the Q can be calculated using product is NH3, right? Oh, since it's all gas, so you're planning to use pressure, right? Pressure of your NH3 to the second power divided by the pressure of your N2 first power, pressure of your H2 to the cube, right? That's how you actually calculate the value of Q. All right, the pressure of your H2 is, okay, NH3 is 2, right? So 2 to the second power. Pressure of your N2 is 0.5 to the first power. Pressure of your H2 is 1 to the cube. Okay, so once you do that, you know this will give you a value of 8 for your Q. Okay, so let's actually, once you see those information, you know you have to calculate your Q. Okay. Okay. So once you see this, okay, then in combined with the keyword delta G naught, the keyword delta G, right? Delta G naught, and Q. They will lead you to the equation number 3, right? Which is delta G equals to delta G naught plus RT natural log Q. Okay. Once you know that it's actually equation that you need to use, then go back and check your question again. Okay, then you'll realize that your delta G naught is negative 32.9 kilojoule, right? So converting to joules, it's going to equals to delta G naught is, oh sorry, delta G naught is this value. My bad. So you want to calculate your delta G. Your delta G naught is negative 32.9 times 10 to the third power. That's how many joules that you have. Plus R is 8.314. Temperature is actually 298 K. Natural log Q is 8. Okay. So once you do that, you should be able to get your delta G equals to negative 27748 joules. Okay. And then convert it to kilojoule, they will give you an answer of negative 27.748 kilojoules. Okay, so that's actually how you get this answer. Right? Okay, so any questions? Okay, so if not, let's look at this. What is the delta G for that reaction for given temperature at 400 K? Will the reaction go toward the product, reactant, or is at equilibrium? Given the pressure of N2 is 4.2 bar, H2 is 1.8, and H3 is actually 2.1, and the K is 41. Okay, so how do you actually solve this? Okay. When you read the questions, what can you learn? The first thing that should actually catch your eye is that it gives you the condition of your reactant product, right? So once you see that, what do? Solve for Q, right? So yes, that's actually the thing you need to do first. Okay. So you want to calculate your Q. So Q is again pressure of your NH3 to the second power, pressure of your N2 first power, pressure of your H2 to the cube. Okay. So right now your PNH3 is 21 square. PN2 is 4.2. PH2 is actually 1.8 to the cube. Okay. Once you have this, what is the Q you're going to get? Anyone have calculators? If I forgot to calculate the number. 18? 18? Okay. Okay, so now you know, let's say your Q, right? And then if you read the question again, what is the things they want you to calculate? What is the delta G, right? So delta G is actually a thing they need to calculate. Okay. And then the only equation that contain your delta G and the Q again is delta G equals to delta G naught minus RT natural log Q, right? So right now you know the Q, you know the T, therefore the second term is actually can be calculated, right? Oh, sorry, pause. My bad. Okay. So with the Q, T, you can calculate the second term, right? R is 8.314, T is actually 29, T is 400K here, right? And then natural Q, so the second term is actually can be calculated, right? But do you have delta G naught? You don't have delta G naught here, right? But you know, we can compute delta G naught using equation number 2, right? So you know, delta G naught is equals to negative RT natural log K, right? So if you want to calculate your delta G naught, all you need is actually equilibrium constant K, right? Do you have K here? Right, you see the K? Yeah, so if you give you equilibrium constant K, that means actually you can calculate your delta G naught using equation number 2. Okay, so that's actually what you need to do. Okay, so if you do that, negative R, so this one you can rewrite this as a negative RT natural log K plus RT natural log Q. Okay, so R is 8.314, T is 400, natural log K is 41, plus R is 8.314, T is 400, Q is natural log 18. Okay, so once you do all those calculations, and then you're going to get a value of negative 219. What's the value? If you do this calculation, what do you get? $2,000. 27. Okay, so is the Q really 18? Everybody that? Okay, we need to have some consensus.
I can read
calculation, okay? Okay. Okay, so let's do it first. Is the Q correct though, first? Everybody got that number? Everybody got 18 here? Okay, so I guess I put everything correctly, right? 3H2 4.2. Okay, so I guess I should be fine. Okay. And then K is 41, right? Okay. So RT natural log 41. And then what do you get?
That's a negative.
Okay. I'll just put this number here, okay? Something like this in joules. Okay, so it will be negative 2.737 kilojoule. Okay. Right. But let's actually how you solve it. Okay, that means actually this cannot be writing. And to actually correct this. Okay, I will. Sorry, everybody know I'm running late, right? Typically, before I come to the lecture, I will actually check out all the calculations. Yeah, today is kind of like the exceptions. I got trapped in the city for 1.5 hours. It's crazy. Traffic is actually, I don't know what's going on, but you know. Yeah, but that's actually pretty much all the things that we learned for chapter 16. Okay, that's all. Okay, and I'm done with the lecture today, actually. Yeah, so I want to actually talk. Everybody fine with this? Okay, good. Okay, so remember, so let's quick summary about the things that you really need to memorize for chapter 16. Okay, and then you should actually go back home and do your homework and then quick as quickly as possible. Okay. The first important concept here is that entropy by itself is actually describing how many ways that your system can store the energy. Okay. The more way you can store the energy, the chances are it's going to happen spontaneously. Okay. To determine whether a reaction will happen spontaneously, there are actually two parameters. First is actually delta S universe. Okay. If delta S universe is positive, then the reaction will happen spontaneously. Okay. The second parameter is actually your delta G. If your delta G is negative, then it will happen spontaneously. Okay. You need to know the delta S universe is the sum of delta S of your system and the delta S of your surrounding. And the delta S surrounding can be expressed as negative delta H divided by the temperature. Okay, so those are the fundamental things that you need to know. Okay. More advanced and calculator related, we have three equations. The first equation is actually delta H, and delta G equals to delta H minus T delta S. Okay. Second is that delta G naught will equals to negative RT natural log K. The equation is delta G is equals to delta G naught plus RT natural log Q. Okay, so those are the three most important equations that you need to actually memorize. Okay, so besides those equations, now I want to actually ask you, test how much you actually understand this. Okay, so if you draw a diagram like this, where the x-axis is delta H, y-axis is delta S. Okay, of course, here is actually positive, here is actually negative. Here is positive, this is negative. Okay. So I want to ask you, under what conditions the reaction will become spontaneous? Okay, so under what conditions the reaction will become spontaneous? Okay, let's start from here. If I'm in this first zone, okay, so in this zone, your delta H is, who say positive? Okay, I did not say the first four. Yeah, so in this zone, okay, the delta H is negative, right? Delta S is positive, right? So if the reaction fall into this condition, will that reaction be spontaneous or not? How do you know? What is actually the variable or parameters you use to decide whether a reaction is actually spontaneous or not? Either your delta S universe or delta G, right? And how do you write your delta G? Your delta G is delta H minus T delta S, right? Okay, so let's look at this. Your delta H is positive or negative? Negative, right? Minus temperature is always positive, right? The Kelvin is start from 0, right? So temperature is always positive, right? How about your delta S? Positive, right? Okay, so negative minus positive. So your delta G will always be negative, right? Everybody see this? Okay, so if you fall into a specific zone or quadrant, so all reaction will be spontaneous, right? All right, so this is actually how you make the judgment. So everybody fine with this? Okay, we're going to do another 3 more practice. Okay. Practice number 2. Let's look at this zone. Delta H is zone number 2. Okay. Delta S is, okay, so your delta G is delta H minus T delta S, right? So you know your delta H is positive, right? Minus your temperature is always positive. Your entropy in this zone will be negative, right? So your delta G will always be positive, right? So in this case, what does that tell you? All the reaction in this reaction is not spontaneous. Okay. So all reaction is not spontaneous. Okay. So that's actually our zone number 2. Zone number 3. Okay, so in this case, your delta H is positive, right? Your delta S is positive, right? So your delta G is delta H minus T delta S. You know your delta H is positive, right? Minus your T is positive, right? And then your delta S is also positive, right? So in this case, when would you have a negative delta G? So this one, the delta G will only become negative when the temperature is what? Right? So if you have a high temperature, then the reaction will be spontaneous. right? So this is actually how you make all this judgment. Okay, you really actually get familiar with all this sign so that you can predict, okay, whether the reaction is going to become spontaneous or under what conditions then the reaction will become spontaneous. All right. So the very last zone. Okay, so delta H is negative, right? Delta S is also negative, right? So you know your delta G equals to delta H minus T delta S. Your delta H is negative, okay? Minus temperature is always positive. Right now, your delta S is negative, right? So under what conditions you will have a spontaneous reaction? Yeah, when you have low temperature. Okay, so you have low temperature, then you have spontaneous reaction. Okay, so this is actually a good examples like cover all the possible combinations. Okay, so this is actually some analysis you need to learn how to do it so that for some conceptual questions, you know how to answer them properly. All right. So any questions for this? Yes. Yeah, this quadrant, okay, it will become spontaneous only when you have a low temperature, right? So that you can make sure that delta H will be the dominant term, right? That will lead to a negative delta G. Okay. All right, so let's probably actually very important concept for all the conceptual questions you are going to encounter for this chapter. All right. So in the following couple minutes, I want to actually talk about the things that some of you may be interested. Okay, so I want to talk about the necessary documents that you will need if you intend to apply for a PhD program or a medical school. Okay, I know guys, you guys are still very young, okay, but you should actually start to think about what are the future directions you're actually headed to. Okay, of course, you might want to go to industry to earn some good money. That is fine too. Okay, we can talk about that in the next communication. Okay, but today I want to really focus on the things that you probably will need for those applications. Okay, how many of you actually know the necessary documents for those applications? Huh? Either medical school or graduate school. Okay, just shout it out. It's fine. Huh? What is the first thing that they look at? Transcript, right? Your cumulative GPA is something they always look at, right? So what's the purpose of that? Screening, okay. So every year, all the PhD program and then the medical school, they got a lot of applicants, right? So they may be actually recruiting 50 students, but the application may be 1,000, right? So they want to have an effective way to do this really fast screening. Okay, so and that thing everybody use is your cumulative GPA. Every school they have an internal requirement for that. Okay, and every school they are different. Okay, the more competitive program you're looking at, the higher GPA they will actually set. Okay, so typically from my observation, I think the medical school probably is actually the one with highest standard, right? So the cumulative GPA they are looking for probably is actually something around 3.8. It's crazy, right? 3.8. So if you want to actually go to medical school, you really need to pay attention to your GPA. Okay. There are actually many other things. If you don't pass the GPA bar, whatever you do is meaningless because they won't see it. Okay, so you will be actually blocked in the first door. Okay, there will be someone. It's not even the review, even not the reviewing committees. Okay, they won't be able to actually see your stuff. Okay, you will be just be caught. Okay, so if that is actually your goal, then that's something that you want to pay attention to. All right. For the PhD, it's a lot more forgiving. Okay, so doesn't mean the PhD is actually not as smart as the students in the medical school. Okay, PhD typically the cutoff varies. Okay, for a not so for the good tier 1 university. Okay, you must have minimum 3.0 GPA. Okay, but the better you go, okay, the higher it will be. Okay, so for example, the best university in terms of ranking, okay, in Texas will be the UT Austin, right? So there for chemistry, okay, just chemistry, the GPA requirement is actually 3.5. Okay, so you know, UH and there will be actually a range, right? So you can imagine that. Okay, so but that is actually something that you want to pay attention to. So GPA is something that you need to actually have a good let's put it this way, okay, to actually prepare yourself so that you can at least get a good enough GPA for the application. Okay, so once you pass that door, okay, then they will be start to be reviewed by the reviewing committee, right? Then the GPA could be actually a very interesting part. Okay, if you actually pass the bar and then your GPA start to be reviewed by the committees. Okay, so they're actually looking for two kind of person. Okay, first person is like, okay, you are actually extraordinary. Okay, your GPA is always very high. Okay, so perfect golden kids. Of course, you got the ticket, that's fine. Okay, you can actually go to the next reviewing criteria. Okay, the other kids they like a lot is that you did poorly in the beginning, but you know, you become one of the best in the later stage, right? You show this positive trend. That is actually very attractive. Okay, sometimes I feel like we may actually prefer those kids who fail in the beginning but coming back afterwards. Okay, meaning actually you have good how do we call it resilience. Yeah, so it's actually I feel like more and more reviewer committee focus on that perspective. Okay, sometimes they consider this actually maybe even more important that you are always a golden kid because we start to worry about the kids that never fail, or many people fail in the graduate school, right? So that becomes actually a concern, especially right now. Many professors, okay, when they do the research, it is actually scary if the kids cannot actually handle those pressures, right? If they cannot handle those failures, it becomes a scary situations. Okay, so those are the two type golden kids that they are looking for. Okay, and after those two types really based on okay who got the better GPA, then you will be picked first. Okay, but that is actually not all. That's actually just the first things they consider. Okay. Besides GPA, okay, the next things that you need to actually pay attention to is that you need to actually write one thing called the statement of purpose. Okay. In that statement of purpose, okay, to show you are the one they will need. Okay. And then, okay, there are actually specific content you want to actually put in the statement of purpose. Okay, so we can talk about that later. Okay. The third document is what? Huh? Yes, letters of recommendations. Okay, this one I feel is actually the one that student, most of students actually did it wrong. Okay, so how do you get your letter of recommendations? You reach out to the professors, right? Okay, so who you need to actually reach out? Thank you. When? Huh?
preferably a semester after you've done it, so there's not.
Oh yeah, there's a few things that you need to know. Okay, this is rules. Okay, you cannot ask me to write you a recommendation letter when you are my student. Okay, it is okay when you were my student. Okay, so the reason I cannot write a letter for you now is because we have conflict of interest. Okay, so in the school policy, it says I cannot write a letter for any student I'm teaching right now. Okay, so don't ask your professor who is actually teaching you right now to write you a letter. Doesn't work. Okay, if you say yes to you, then he doesn't know the rules. Okay, it is actually not allowed. Okay, but you do need to actually ask for a letter, right? So when I say, okay, who you need to actually ask for it? Okay, so many of you just point to me, say, you can ask a letter from me, right? So it actually that is not exactly the answer I'm looking for. Okay, so a few things you want to know. When you want a recommendation letters, okay, what makes the letter strong? Yeah, when the professor knows you. But do you feel like I actually know 300 kids? Yeah, impossible. That's impossible, right? So how do you actually find some professor who knows you? So if you just actually targeting those professor who serve as your instructor, most of the time, this will be the letter, right? Okay. Let's use Adam as an example. Okay, so let's say, okay, Adam is a student who took my CHEM1312 in 2024 spring semester. Okay, and he did pretty well and ranked X out of certain number of students. And that's it. How do you feel? How strong is that letter? Is that the letter going to get you into the dream program that you want to actually have? No. Right? If that is actually the letter we receive, you're done. Right. So apparently it's just a few things. That's actually what the review committee is going to think about it. Okay. I've been doing the review committee for many years. Okay. If I see a letter like that, what it tells me is that first, the professor doesn't really know the student. Right? Second, the student have no idea what letter that he should actually have. Right? And then most likely the student actually acts the letter at the very last minute. Right? And then that is actually irresponsible. Then why do I want to hire someone irresponsible to my program? So that is actually thinking that the review committee is going to have. Okay, so it's really bad, right? Even though it did not say anything bad, but it's actually a very bad recommendation letter. It's not an okay recommendation letter. Okay, so that's something that you need to know, right? But how do you actually get a strong one? Yeah, so the best recommendation letter you can have is actually coming from someone who truly know you, who can actually comment on your personality, who can actually comment on your intelligence, right? So those are the people that you need to actually ask for the letter, right? But how do you actually make those people appear? There you go. Okay, so you are going to actually take many courses before you graduate, right? Pick the one that you like. Okay, just keep knocking his door or her door, so like he will actually know you. Okay, and do your conversation. Share with him about your personal experience. Tell him some of your story that shows you are smart, strong, and beautiful. That's actually how you can get a strong recommendation letter, right? Because once they know your story, then once they know what you want, then he can just tailor his letter to your dream. right? Then when we see those things, we know, oh, okay, this guy is really doing a good job, right? He's actually asking the right person to write the recommendation letter, right? And in the letter, it truly shows that the student is actually someone worth our time to really think about whether this guy is actually can fit into our program well enough. Those are the letters that you will need. Okay. So everyone have a better idea about who to ask for letters? Okay. Second question for you is that, does the letter always need to come from a professor? No. Okay, it has to come from someone that know you, who can actually provide a professional evaluation that is actually relevant to the program you want to apply. Okay, so this is actually a very delicate job you need to do. Okay, if you do it well, you make yourself very strong. Okay, because most of the kids, they do it sloppily. Okay, they did not actually really do it right. Okay, so next question will be, when should I actually start to prepare my recommendation request? Okay, so the true answer is you probably actually want to reaching out to professors now. Okay, because let them know you takes time. Okay, but if you do it like early enough, okay, and then you can always have good relationship with a professor after you finish his or her class. Okay, then he will gradually actually know you. Okay, and there will be actually when you hit your last semester. Okay, in the beginning of your last semester. Actually, before that, okay, you can during your conversation, you can actually try to ask whether he or she is willing to write a letter for you. Okay, so again, it's coming from your conversation with your letter writer, right? You need to actually let them know you. You need to let them know what's your plan. Okay, showing that you have a plan is important. Okay, because many kids, they don't have a plan. Therefore, by the time they graduate, they feel panic. Okay, it's actually a very sad story, but that's actually what I always see. Okay, so many students who maybe take my courses in their very last semester. Okay, and then after the course, they will come to me and say, Dao, I don't really know what to do. Right? I doesn't really actually start to think about what I want to do while I'm a bachelor student. Right. So I don't want those things happen to you. You guys are great. I mean, you guys are very young, right? So you have enough time to start to think about the things. Okay. So recommendation letter is actually something it will take you time. Okay, not just a month, not just a semester. Okay, it probably take you a couple years to get a very, very strong recommendation letters. Okay, so those are the things you can actually start to plan ahead. Okay, if you show that you really want to actually pursue certain things, most of the time the professor will be willing to help you. Right, like I said in the very beginning of the semester. Okay, I really want to help those students who really want to help themselves. Okay, so those are the things you need to actually demonstrate. Okay, not just saying, but demonstrate. Okay, to your letter writer. Okay, so that's pretty much okay. The third documents and then a few concepts about the recommendation letter. Okay, but I've been actually talking about like what is the contents that should be covered in the recommendation letter, right? What are the material to actually supply for your letter writing? Okay, we can talk about that later. Okay, so I want to get back to the statement of purpose a little bit. Okay, so sometimes this is actually a very, very fun part that I feel like everybody have different style. Okay, so how would you write your statement of purpose? But actually, the student actually have no idea, right? You don't know what is actually relevant. What is the things that we want to actually see, right? So some students start to actually introduce like him or herself, and then talk about her family members, and then write very long letters. Okay. And those letters is not effective. Okay. So a few things that you want to have in your statement of purpose. First is that you want to discuss your academia performance, right? So if you have a very good GPA, share with the committees about how you actually achieve that. Okay, if you have really poor GPA but become very strong later on, explain why. Okay, so first part is always discuss your academia performance. Okay. The second part is what?
Not just like, oh, I have a 4.0, but like I have a real passion for this, like, I can't stop thinking about.
Okay, so good. Okay, that's good. Okay, how? What can you use to show that you really want to actually get into the program? Huh? Okay, so
Okay, research.
okay, using examples, right? So you cannot just say, okay, I really want to get into the program. Doesn't work that way. Okay, that's what you say. Doesn't mean that's what you did. Tell me the examples. Tell me the things that you have done that will support the argument, right? So what could be actually a good example that you have? Mm-hmm.
Rocks.
Mm-hmm.
And I just like, I love rocks. My uncle's a seismologist and my dad's a petroleum engineer. So I just like, I love everything to do with like seismology and geology and all of it. And I've been like obsessed with rocks since I've been a little kid, and I've like never wanted to do anything else.
Okay, so that is actually something okay. Okay, that shows that you have a clear reason why you want to do this, right? But everybody can have that, right? It doesn't actually make you really stand out, right? So what are the things that can actually make you stand out? Huh?
Like hardships or something, like, well, I had to make it through this.
Okay, so let's just give some examples. Okay, let's say you want to get into the chemistry PhD program, right? The most important one will be you already do some undergraduate research, right? Doing the undergraduate research, you will know exactly what to write, because every time you go into a lab, if the lab is actually good, you are going to have a project. Okay, a project that fits your level, right? So once you start to describe your project, then you can going to say, okay, during this process, I've learned A, B, C, D skill that's actually relevant to this program, right? So laying out all of things already show, okay, you are actually being really serious about this, right? So you already have all those experience, even though not perfect, but apparently you're actually doing it. Okay, so that will be actually a good example, right? Undergraduate research is always something good that, and I encourage actually everyone to do some undergraduate research. Okay, it's actually a fun experience. Okay. And then the other thing is actually, some people say about the intern, right? Intern could be actually a good one too, if it's actually relevant to the things you want to do in the future. Okay. Volunteer experience is good. Okay. Many of you want to go to dental school, for example, right? Then you say you have been working in the practice for many years, right? And then during there, you learn A, B, C, and D, right? And that's actually all relevant. Okay, so those are the relevant information you want to actually cover inside your application. Okay. Okay, so let's conclude the second point, basically, right? The first point is actually your academic performance, right? Second point is actually to have some relevant experience to show that you are being very serious joining that specific program. Okay. Third one. What's the third important point? Another plan. Your personality. Okay, so nowadays the questions people want to address become more and more complicated, right? Okay, so most of the time we need a team to solve a complicated problem, right? Do you have any example that you can show to demonstrate you are a team worker? Okay. Yeah, and then do you care about someone else? Okay. Another thing that people start to actually pay more attention is that can you accept criticism? Okay. Are you the one who can actually accept those criticism, learn from it, and move on? Right. Okay, it's actually more related to the resilience. Okay, so you need to actually give examples for those things. It's more about your personality. Okay, so there will be actually the third one that's actually very important. Okay, the very last point I would suggest will be specific about the things you will really enjoy when you join the program. Okay, and the example I want to show is that, okay, for example, I want to actually join the chemistry PhD program. Okay, then I will need to do my homework. Okay, I want to actually browse through the website of Chem department and identify 3 professors that I like. Okay, so if I can really pinpoint a few examples in that specific program that you really want to actually participate, it actually make you very strong because we know you are not just using one application for all, one document for all the applications, right? You actually tailor it into the things that you want to actually pursue. Okay, so that is actually one great way to show that you are very serious about your application. Okay, so recap. Okay, the content that you should have for your statement of purpose. First, discuss your academia performance. Okay, talk about your GPA, talk about the award you have won in the past. Okay, and how you actually reach those great achievements, right? Yeah, so that's actually the first thing you need to actually discuss. Okay. Second is actually, are there any relevant experience? Okay, that shows you're actually serious about that program. Okay. Third one is actually more about your personality. You already show that you cares about others, right? For example, you're doing the tutors for some younger kids, right? Or you do the tutors for the UH students, right? Demonstrate you actually care about someone else, right? And those are all good things that you can put into that third point, okay? And the very last 4 points actually be specific, tailor your application to that specific program, okay? Highlight the names that you like to actually work with. Okay, so with all those 4 elements, it will actually make your statement of purpose a lot more meaningful. Okay, so I see many of the statement of purpose actually they write very long paragraph, but they don't even mention any of this, right? Then it is not an effective writing. Okay, so those are the things you probably want to do for your statement of purpose. Okay, yeah, so any questions or any other things that you would like to know that I can just share with you? Yes. 2 pages.
Okay.
So think about this. Okay, this is actually how I feel. Okay, I review hundreds or 200s of applicants. Right. So if you make it very long, when I go through maybe 2 pages, I lost my focus. Okay, so if I lost my focus, that means actually I won't actually really spend time trying to dig out the information that I want to dig out. It's just human. Okay, so all the reviewers, they are just human, right? So you want to take it into consideration. Okay, and the other thing that you want to actually think about is when you prepare your documents, have a clear format is actually helpful. Okay, so you want to actually pay some attention to that. Okay, make sure that you have clear structures of your writings, and those are good things to have.
So this is also like, this is applied, I plan on going maybe just master's program, I don't know.
That's totally fine.
And this is that like the same kind of, like you're gonna do, what was it called that the 2-page paper document that we
Statement of purpose.
Statement of purpose.
Yeah, it's all the
Also
same.
Statement of purpose for master program.
Yes, the same. So you actually using the same document for those applications. Yeah. Mhm.
So if you're writing a statement of purpose, saying like your first internship or your first experience with undergrad research, and the fourth section you talked about where provide like specific examples to show that you're like interested.
Mhm.
But if you're applying for your first, undergrad research internship, you might not have those kind of like very specific examples
Mhm.
apart from being class interested or whatever. So what would you do with that?
Yeah, very good questions. Okay, so last year I actually received a lot of students. Okay, they were my students. Okay, and then after the lectures, they want to actually do some undergraduate research with me. Okay, and then these are the things I ask for when they actually submit their applications. Okay, the truth is actually not all the professors want you to actually submit any documents. Okay, but some professors who is more serious about the undergraduate research program will have actually a higher standard for the students. Okay, so the document I asked them to send me, including first, your transcript, right? Second, your statement of purpose. Okay, why you think, why you want to actually do the research with me. Okay, and then, and on the third one is actually your CV. Okay, those are the documents I asked for. Okay, so at those are the documents I asked for it, right? So there'll be, I don't know, I received 10 application last year. Okay. The way I eventually pick up the students actually, do I really know these students? Okay, so eventually I pick up 3, and those are the 3 students that I know quite well, and then they do quite well, and then in their statement of purpose, I feel like I can actually communicate well enough. I can provide enough training for them so they can actually move toward their dream with a. I feel like I can be beneficial for them. Okay, and then I also feel that they want to contribute to my research lab. Okay, so whenever professors they don't take the undergraduate student research seriously, it's because they're actually burning the resource for your own achievement. Okay, because you don't actually know much, right? You're undergraduate student, you're trying to learn something, right? And therefore, when you go to the lab, okay, if they're willing to actually have for example, a graduate student or postdoc to work together with you, so you can actually learn those fundamental skill set or knowledges, okay? And then using all the instruments that the lab have, right? You actually using a lot of money from the lab, okay? So the way the lab work is actually the PI got the money from the federal government, right? So they purchase all the instruments, purchase all the chemicals, so you can do some research, right? And all of things are very expensive, right? So if you can see someone who is willing to provide the opportunities, okay, and then you feel like you can actually work with the PI, that is actually a great opportunity to improve yourself. Okay, so I would say that if you want to really make yourself stand out, one thing you can probably add is that to show that you are actually very serious, you can commit, okay, I am willing to actually work X hour per week, right? So that we know you're actually serious. Yeah. And you want to make sure you have a good communication between you and the advisor. Okay, because those advisors eventually will be the one who's going to write a letter for you. Right. So you want to have a good relationship with them. But at the same time, you also don't want to waste your time. Right. So there's actually no one good professor fits all those scenario. Okay. We like you talk to professors, you feel like, okay, it's very easy and understandable, right? And then you share common values. Okay, so those are the professors you want to actually work together with. Yeah, and showing that demonstrate how committed you are I think it's actually a very, very important thing for the undergraduate researcher. Okay. All right. Any other questions? We're actually running out of time. Yes.
For the surveys, the same. Survey is the same thing.
We won't have survey this time.
Oh, we don't.
We won't. Okay. So the survey actually you got 1 extra credit, right? So we are only allowed to give 2 extra credit. One is actually the midterm survey. The other one will be the one you do the final semester evaluations. Yeah. Yeah. Just screenshot that, then you'll get 1 extra credit. Okay. So if there's no more questions, I guess they will be for today. Yeah.
A question regarding partial credit.
Mhm.
So for the partial credit, do you want us to explain what we deserve